As you've learned, there are two main data models for GIS data, vector and raster. Additionally, GIS data comes in many file formats. When gathering data for a project, it's common to acquire data from several sources. Therefore, it's also common for the data to be in several different file formats and spatial references. In this lab, you'll create a project geodatabase for the Gifford-Pinchot National Forest in Washington State. The first step will be to normalize the data. This means that you'll put all the data sets in the same coordinate reference system and clip them to the study area boundary. Lastly, you'll put them all into the same file format, namely a spatial-light geodatabase. In this task, you'll familiarize yourself with the lab data and begin normalizing the data. So here I have QGIS browser open, and I've navigated to the Lab2 data folder. As you can see, there are 8 layers in here. There are 4 shape files, 2 KML files, and 2 coverages, Ranger District and Admin Forest. And note here, when you have 2 coverages in the same folder or workspace, they share the one info directory. So this info directory has attributes for both of these coverages. While I'm here, I can look up the coordinate reference system of each layer. This will tell me which layers will need to be saved to a new coordinate reference system. For this project, all the data is going to need to be in UTM Zone 10 NAD 83. So if I can start down here with this watershed layer, click on that, and it switches to the metadata tab where I can see that this is in UTM Zone 10. I can click on the KML for streams. KML only supports one spatial reference. It's always in WGS84 geographic. The trails are in UTM, so the watersheds and the trails are fine. They're in the spatial reference that we want for our project. The roads are too. We know the lake, since it's KML, will be in WGS84. So let's look at this vegetation layer. This one's in a custom Albers equal area. This plus proj equals AEA stands for Albers equal area with the parameters following. We also have these 2 coverages. I'll expand the Ranger District and select the metadata XML, and I'll see that this is in Albers equal area as well. And I'll expand Admin Forest and do the same, and see that that's in the same Albers equal area. So we have several layers that are in the correct spatial reference for our project and several that are going to have to be reprojected. So now I'll bring up QGIS Desktop, and I'll add that Admin Forest coverage. So I'll use the Add Vector Data button, and remember, when I'm adding a coverage, I'm going to choose a source type of directory and then change this type to ArcInfo binary coverage. And I'll browse, go to the Lab2 data folder, and I'll select Admin Forest and click Open. This will give me the select vector layers to add, and I can choose which ones I want to use. I'm going to use the polygon layer, so I'll click OK. I've added my coverage to QGIS Desktop. This layer is going to be the study area boundary. It's also in that custom Albers, so I need to get this into UTM. So to do that, I'm going to right click on it and choose Save As. I'm going to put the output as an Esri shapefile, and I'll browse to select the location. And I'll call this admin forest.shape. Next, I need to choose the coordinate reference system for this. I'll click the Browse button next to CRS, and I'll use the EPSG code for this spatial reference, 26910, which is UTM Zone 10. So I'll click OK. Now I've populated everything I need to, and I'll click OK to reproject this. And now I've got a new version of Admin Forest in the UTM coordinate reference system. So I can get rid of the original one. I don't need it anymore. I'll be using the reprojected one. You'll repeat this same step for the Ranger District coverage. The only other data set in Albers equal area is the vegetation shapefile. So I'll add that by using the Add Vector Data button. Source type will be file, as it usually is. And I'm going to set the filter to Esri shapefile and select the vegetation layer. Now remember, I can double click on this to confirm that this one is in Albers equal area. I'll go to Save As and save this out as a shapefile in the new coordinate reference system. I'll leverage the original name and just add UTM to the end. Choose the coordinate reference system. Now it's in my recently used coordinate reference system since I've already reprojected the first 2 layers. And I'll click OK with everything filled out. This takes a little bit longer because it's a much more complicated and larger layer than the first 2 I worked with. Now it's done. You can remove the original one. And so now I have 3 layers that used to be in Albers now saved out to shapefile formats and the UTM coordinate reference system. Now I'll add the roads and the trails and the watershed, which are already in UTM. Roads, trails, watersheds. Click OK. So these are in the right coordinate reference system, but they extend beyond the boundary of our national forest, our study area. So these are going to need to be clipped. To do this, I'll go to the Vector menu, Geoprocessing Tools, Clip. So I'll start with the roads. That'll be my input vector layer. The clip layer is going to be Admin Forest. And I'll click Browse to choose the output. I'll call this NF Roads Clip. Click OK. Again, this is a slightly large layer, so it's going to take a moment for it to process. And when it's done, we'll have a roads layer that is confined to the extent of the national forest. So that's finished. And one thing you might want to do is make the admin forest hollow. So give it a fill style of no brush with perhaps a green outline, since it represents national forest. And you could make this the uppermost layer so you can see that the clip operation actually worked the way you intended it to. I can also get rid of the original roads layer because that was an intermediate data set. In the lab, you'll also clip the trails layer and the watershed layer to the national forest boundary. At that point, you'll have 6 of your 8 layers in the coordinate system for the project, and they will have all been clipped to the study area for the project. The last 2 layers, rivers and lakes, are KML files. And remember, KML is always in a geographic coordinate system with an EPSG code of 4326. Since their CRS is not a custom one and has an associated EPSG code, these can be reprojected when we import them into the Spatialite database. In the next task, I'll cover how to create a new Spatialite database.